Class-agnostic object detection with multi-modal transformer. Class-agnostic object detection is a two-way classification differentiating objects from the background. Despite being an apparently simpler problem, class-agnostic object detection is indeed challenging from the perspective of representation learning. This paper creates a benchmark for generic class-agnostic object detection using multi-modal vision transformers on diverse domains. Notably, it demonstrates state-of-the-art performance of pre-trained MViTs towards class-agnostic object detection with the use of simple, human-understandable text queries. We considered two recent MViTs for this study and also developed an efficient and flexible multimodal VIT, MAVL, which performs better in locating generic objects. The first MViT that we considered is GPV1, which has a unified architecture for multitask learning, where the type of task is inferred from the text prompt. The next MViT considered is modulated deter, trained to detect objects from an image conditioned on a text query. MDeter finds it challenging to scale to high-resolution feature maps due to its fixed self-attention design. To this end, we propose multi-scale attention VIT with late fusion, MAVL, using multi-scale spatial context, deformable attention, and multimodal fusion. Our model shows faster convergence and competitive performance against MDeter. Similar to MDeter, our model trains on the LMDet dataset, which contains 1.3 million aligned image text pairs. Here we compare the class-agnostic performance of MViTs on 5 natural image datasets, with bottom-up approaches and unimodal detectors trained in class-agnostic fashion. We demonstrate that MViTs excel at class-agnostic object detection. We now show the generalization ability of MViTs by evaluating class-agnostic object detection performance on 5 out-of-domain datasets. In order to demonstrate generalization to novel classes, MViTs are evaluated on rare categories that have no or very little occurrences in the training data. Here we present the class-agnostic object detection performance to various intuitive text queries and the effect of combining them, which helps in capturing the global context and reduce the dataset biasness to any specific query. We now present some interesting application of class-agnostic object detection using intuitive text queries. Starting with open-world object detection, we show state-of-the-art performance with the introduction of high-quality class-agnostic pseudo-labeling for unknown object detection using MViT. We improve upon the recent work DETREC using class-agnostic proposals from MAVL instead of using bottom-up selective search proposals for unsupervised pre-training. We illustrate an interestingly simple application of class-agnostic object detection using interactive text queries such as all salient objects for the salient object detection task. In a similar manner, we show how intuitive text queries can be applied to camouflage object detection, which generally requires a significant amount of visual perception. We investigate the root cause of such generalization for the concept of objects embedded in MViTs. We first ablate the effect of supervision and find that the combination of vision and language supervision is critical. However, through a series of systematic experiments, we find that it is the language skeleton or structure rather than the lexicon itself that defines this strong understanding of generic object definition within MViT models. In conclusion, we demonstrate state-of-the-art performance of pre-trained MViTs towards class-agnostic object detection via a set of human-understandable natural language queries. We show the benefits of such class-agnostic object detection on various downstream applications and analyze the factors that majorly contribute to the improved performance of MViTs. Thank you.